Okay, students. So, from exercise 10.2, question number 2, I guess you can do yourself also, and most of you maybe have solved already, right? So, you can check this question. Very simple. Prove that if chords of congruent circles means there will be a circle whose radius will be same. Okay, congruent. I hope till now all of you have understood. We have discussed many times, and in class 8 also we have discussed congruent many times. Okay, so prove that if chords of congruent circles subtend equal angles. So this is basically proved, you can say. Okay, so they have said chords of congruent circle subtend equal angle. So chord, they have said chord subtend equal angle means it will subtend equal angle at the center, they have said, right? So whatever this chord will subtend made angle here, exactly same angle it will make here. That's what they have said on the center. Now they didn't say that chord are equal. Okay, this time they have said these angles are equal according to question. Now in your exam also I told you, right, when I gave you midterm questions review, I told you how to solve geometry problem. Always see the question, interpret the diagram, and then try to see what informations are given. Try to collect those information. If you have doubt, you can write down in the rough also what information you have. Okay, and then see what you have to find. Now in this case you can see, so here what are the information given is they have given the angle made by the chord are equal. Only this information is given. You can check, no other informations are there. So only I know that this is equal. This is what it's given. So with the help of this only I will try to solve. So see here carefully what they have asked. Then the chords are equal, you have to prove. So prove that the chords are equal. So I have to show this one, it is equal. Now see, only with this angle equal can you show this is equal, this chord is equal. What property you will use, right? Now see, this angle equal, right? Now if I look carefully the diagram here, you can easily see that this side and this side, it is nothing but radius here, and this side and this side, it is also radius. Now they have said these are congruent triangle. Congruent triangle means they are of same size and same shape, means their radius also will be same, otherwise they cannot be congruent, right? So if their radius are same, can I use side angle side congruency and can show that these are equal? So very simple question this one. This I have already discussed, you can say in theorem, exactly same question was there. This is nothing but theorem, you can say. Okay, so I have already discussed there that one. Still those who were not able to do, you can see this and can write down yourself also. Okay, so what you do is just name it first, these things. P, this is A, B, C, D, that. Okay, so you can write down here given A, B and C, D made or subtend means made only. Okay, made subtend equal angle at the center of congruent triangle. Center of congruent triangle. Okay, now in what I will do, in triangle this and this I will show it is congruent. In triangle OAB and PCD, triangle PCD, OA is equal to PC radius, right? Radius of congruent triangle, you can write radius of congruent circle. What I'm saying, congruent circle, right? Not triangle, this is not triangle, right? So radius of congruent circle. Next, angle AOB, or you can write angle O directly, is equal to angle CPD. Here you can write directly angle P also, no problem. Okay, so this is why equal, because given, right? This is given in the question. Next, OB is equal to PD, so this is radius of congruent circle. Okay, so therefore triangle OAB is congruent to triangle PCD. Okay, how I have shown this: side angle, side congruency. Okay, after that what I can write directly? Can I write AB? Therefore AB is equal to CD. Why? CPCD, because it's a corresponding part of congruent triangle. So after this you have some more theorem whose proof you don't need, and proof is very simple. You can also prove yourself, and you will see that in the book also the proof is not given, but you don't need also. It's a very simple proof, and they will not ask you these things in the exam. Proof they will not ask. Okay, so anyway it's better always to know, right? So see here what the theorem says is the perpendicular from the center. So means if you have a circle, okay, and if you draw from a center, you draw perpendicular. Now perpendicular circle you cannot draw, right? Perpendicular to one of the chord. So suppose there is a chord like this, and if you draw perpendicular from the center to this chord, then remember this line will always bisect this chord. Always bisect this chord, means it will be equal for sure. Okay, now how you will prove that? How I can say that this will be always equal? Very simple. You can see if I draw perpendicular here and if I draw radius here, proof, I'm telling about proof. Okay, then you can easily show these two triangle congruent or not. You can see if I can draw perpendicular here, then if I draw this, construct this, if I join this endpoint and this endpoint, what is this one? Radius. So they will be equal, right? So in this triangle you can see right angle, hypotenuse, right angle, hypotenuse, side. Right angle, hypotenuse, side for this triangle, right angle, hypotenuse, side for these triangles are equal. So they are congruent. So if it is congruent, these are corresponding parts, so this will be equal. Very simple proof, right? So anyway, you just try to remember these things with the help of diagram, not with statement. Statement, if you remember, you will forget for sure after few times. And moreover, while using this statement, these theorems, if you don't know with the help of diagram, then you won't be able to solve complex figure. Okay, complex figure, it will be very difficult to analyze how to use this theorem. So it's always better draw diagram and try to understand what the theorem try to say. Okay, so in this theorem what it says, from the center if you draw a perpendicular to what? To one of the chord, any chord. If you draw perpendicular from the center, then remember that perpendicular line always will bisect the chord. Okay, always it will bisect the chord. Proof I have already said. Construct this radius, that's why it is equal. This is already equal because common, right? And angle, it's 90 degrees, so right angle, hypotenuse side, right angle, hypotenuse side of these two triangles are equal. That's why they are congruent triangle. Okay, so if it is congruent triangle, obviously this must be equal because corresponding part, right? So that's why, that's the proof that these two sides always must be equal of these two triangles. Okay, same with the other triangle. So the statement is like this: the perpendicular from the center of a circle to a chord bisect the chord. Okay, bisect the chord means what? It will cut from the midpoint. Okay, so theorem number 4 is converse of this one. If you draw from the center, if you draw a line such that it will bisect one of the chord, then that line which you have drawn from the center will always be perpendicular. That's what it says. Converse, right? This time what it says in the statement, if a line is drawn from the center such that it bisect one of the chord. If it bisect means what? This and this equal, then always it will be perpendicular. Proof again same, very simple. This is radius, so radius equal. This time this we have to prove. Okay, so this equal, this equal, common, this and this equal, so side congruency, it is congruent triangle. So if it is congruent triangle, this will be equal. Congruent triangle, this will be equal, this will be equal. Okay, so here what you have to do is, if this is not perpendicular, you have to construct. Okay, this is little lengthy but simple proof. Okay, if this is not perpendicular, then you have to construct a perpendicular line here. Okay, so if you construct, then try to show that this will be the shortest line here. Shortest line means this will be the height. Okay, so this will be little complicated compared to this one. Okay, the only thing is this you have to show shortest line compared to this one. This you will learn in class 10. Okay, so that's why you don't need exactly this proof. So this proof is enough right now just to understand. So to prove this one, you will have this theorem again in class 10 also. Okay, exactly same theorem you will have in circle. Number 5, what it says, now see here, when you draw line, minimum how many points you need for drawing a unique line? 2 points you will need, right? Because from 1 point, how many points line you can draw? Unique line you cannot draw. Infinite number of line you can draw. To draw unique line, you will need minimum 2 points. From this 2 point, you cannot draw any more line. So same way, for drawing circle, minimum how many, unique circle, how many points we need? So see here, I will draw 1 point first. So from this point, how many circle I can draw? Infinite circle I can draw, like this, like this, like this. Infinite circle I can draw like this. Okay, so 1 point is not enough to draw unique circle. What about 2 point? So 2 point, is it enough to draw circle? So I can draw this way. Can I draw more? Yes, through 2 point I can draw more circle. This many circle I can draw, right? Now 2 point is also not enough to draw unique circle. Now 3 point, is it enough to draw unique circle? This I have drawn. Now from this 3 point only, can you draw another circle? Obviously this time not possible. If you draw a circle like this, it won't pass from this. If you want to make smaller also, it won't pass from this 3 circle if you make smaller. Okay, so to draw unique circle, you can also try from 3 point. Can you draw properly? You put 3 points and then try to draw another circle from the 3 point. You won't be able to find another circle. There is no other way to draw from this 3 point another circle. So what it says, if 3 points are non-collinear means it should not lie in straight line. If it lies in straight line, then you cannot draw circle. Okay, non-collinear point must be not in a straight line. Okay, so that's what the theorem is. There is one and only one circle passing through 3 given non-collinear points. Very simple theorem. So from diagram it's much more easy to understand all this. So don't try to memorize this one. Always statement, no need to memorize. See the diagram and try to understand from the diagram only. Okay, that will make you remember the theorem easily. Okay, so based on this you can try exercise 10.2 questions. Some of the questions you can try. Okay.